Hello everyone. I want to make this a quick video today. Short version. I bought this bulb on I don't remember, eBay or Amazon. It was advertised as a UV-C LED bulb. Spoiler alert, it is not. So to show that it isn't, I figured I would show why I decided that it is not. I bought a couple of meters to test this thing. You got this one here. This is a UV-A and B meter made by General. And over here is a UV-C meter, also made by General. I also have this meter. This is a visible light meter, and it gives a spectrum, which is pretty cool. So I'll be using that. I also have a genuine fluorescent UV-C bulb, and I'll be testing that at the end of the video. So, I guess so. Here's my test setup. I've got the two probes for the meters, the UV meters, right here. And on this side of the box, I've got another one of those bulbs set up at approximately the same height. The distance between the bulb and my meters here is approximately 1 meter. 1 meter to the meters. So I did that just to get a reading that might be comparable to someone else's reading. I might move this closer later just to make the numbers higher or whatever. Alright, so I'm going to get this set up and I'll be back in a minute. Okay, so the bulb is in this box. I covered it with a blanket to keep all the light in. I already know that it's not putting out UVC, but I do want to be careful. I'm also wearing UV safety glasses. I did want to mention that both of these meters, both the AB on the left and the C on the right, are measuring milliwatts per square centimeter. So, oops, I'm sorry. They are measuring microwatts per square centimeter. A microwatt is a millionth of a watt, whereas a milliwatt is a thousandth of a watt. So, essentially, if this meter reads 1,000, it is getting 1 milliwatt. So, the bulb is in there. You'll see it with the meters again in a second, but here, allow me to turn it on and observe the power. Wow. 0 microwatts at a meter. Okay, so I'll turn this back off and I'll be back again in a second. Alrighty, back. Got the meters down there. Same bulb here. Got the two probes right here. The AB is on top and C is on bottom, so it's ABC. And just to show that the meters are working, I'll put this, well, I thought this would put out some, there we go. We got 5 microwatts from this filming battery powered lamp. Alright, so let me turn this off. Let's turn this light on. There we go. So it is bright. And it is blue. But it is not putting out UV. So let's get the visible light meter into play here. Alright. So I think it's ready to test. Here's the test button on the right side. And there we go. Looks like it is peaking at 400 and well, I can read it. 400 and maybe 50 nanometers. Let's see if I can zoom in on it and get focus. Anywho, I guess Just for kicks, let's put this filming light here. Turn this off. And I'll do another read. And there we go. That's what that filming light is doing. Pretty nice light. Check it out. It's almost 96 CRI. It's pretty awesome. Alright, so that's that. I'm going to put the real UVC bulb in here. I won't do the visible spectrum on that, and it will only be with the blanket over, but, you know, let's take a look. Let's see what this will do. Alrighty, got it back in the box here. Let's see what happens. Nothing. Which makes me wonder if the bulb is on this. Oh, that's right. Power strip is turned off. There we go. Okay, at 1 meter, this genuine UVC bulb, which takes a little bit to heat up, it's putting out 54 microwatts per square centimeter. That's pretty low. But again, it is at 1 meter, so I think I'll move the probes closer in a moment and test it again. Let's watch it climb up just for a bit. Alright, I'm bored. Are you guys bored? Cool. Let's stop this. Okay, I pushed the probes much closer to the bulb. I don't know if I can. Sorry for the shaky cam. But they're now approximately 10 centimeters or 100 millimeters from the bulb. And let's see what kind of readings we get here. Okie doke. Boom. A lot of power. So I'm not going to let this heat up fully, just because I don't feel like it. Actually, yeah, I will. So I'll just pause it and come back. I'll note the time. Okay, it's approximately 1 minute later, and it seems to have leveled off. So at this distance, the genuine fluorescent UVC bulb, I should mention that this is an ozone-free UVC bulb, so it's can be a little less powerful because of the coating or the additive that they add to the glass to keep the ozone-producing wavelengths from being emitted. And we're at approximately 4,600, it looks like, microwatts per square centimeter. Maybe make that 4,500. And falling. I guess I'm going to watch it for a minute and see if it comes back up. Interesting. So it's been 2 minutes or so, and it is continuing to fall. I don't know what to make of that. Don't know how much I care. The video really isn't supposed to be about this bulb, so I'm going to stop it there and basically not care. Okay, I took that bulb out. I put the LED one back in. I didn't move the probes. They're still at about 10 centimeters. They're actually a little closer because this bulb's a little bigger, but you know, I'm not too worried about it. These bulbs are temperature dependent, so I suspect it was losing efficiency because it was warming up. That's my guess. Anyway, let's turn this one on and see what it does. Alright, back. I took out the part where I was fumbling for the switch for the light. Anyway, same setup. Let's turn this bulb on. And there we go. 5 microwatts at 10 centimeters. And, well, you know, it's constant. That's nice. Okay, so if you're thinking about buying one of these bulbs, don't. I guess. Yeah, it's kind of a cool color. Anyway, see you guys. Stay safe, as is the salutation these days, and I'll see you later.